Okay, so I just want to talk to you a little bit about the semiconductor industry. So this is a tool. They call this a tool. They're very similar, like Applied Materials, Lam Research, Varian Semiconductor. I think that's still around. Some of the other company, Intel, of course. Intel Intel usually doesn't make their own chip, so they have other companies like Applied Materials make the chips for them. In case you didn't know that. What we're looking at now here is a device. It's called a like electrical plater, like a PECVD, which is like copper deposition essentially. So this is a tool. This is like an anode, right? A copper anode weighs like maybe 12 pounds, something like that. And then you have your wafer on top, right? Then this person right here is putting what they call a recipe. They're putting in so a lot ID, right? He's calling for the lot. He's calling for like a a FOUP or a lot of 25 wafers. He's calling it, hey, come on in, dump it into this tool so we can plate those wafers. Essentially, what's going on, and he puts in like the wafer slot and all that stuff. And push OK, and then the green button here. So what's going on is the robot, you don't see it, but the robot put the wafer on top here actually, and it's picking up the wafers on top here. This is like your anode, your copper deposition basically, and it has like glass shield. It has little power cords. So it flips it over, the wafer over, right? It sticks it into the bath. The bath is usually like a blue color because copper is blue. Okay, look, it's putting in. Yeah, okay, puts it in and sets it down, and then it's going to plate it. So this is this is what the wafer looks like. That little copper color thing. That's the wafer itself, right? You have around here. You have the so it's smashing it down, picking it up, turning it around, gonna put it back in the bath called copper plating bath, basically, right? Okay, so this is what copper looks like in water form. It's blue. No, it looks oh, it does look well. It looks copper color, right? But when liquid form, it's blue actually. So that's the bath. It put it around. Okay, it's gonna stick that wafer inside that bath. Right here, there are like little power. They're anodes basically, right? And they get charged like a positive charge or a negative charge. So down here, I think it was like a negative charge down here in the ion bath, and then their anode is positively charged, I believe. I get them mixed up sometimes. Anyway, what's going on is the copper is rising or getting pulled to the wafer itself from the bath. It's turning, right? Anyway, when it's done, it's going to take it out and put it into a hoop or back in. Okay. So the next video I want to show you is so these are like wafers right here. Okay. This is from Micron Technology. Anyway, these are wafers. So these little things here, that's 25 wafers. This right here, this is a FOUP. So this is what you're looking at is essentially in the inside of the tool, right? You have two FOUPs, and each FOUP holds 25 wafers, right? And you have a robot that comes in and it takes the wafers, right? It takes the wafers from the machine, from the tool, and puts it back into the FOUP. And then the that FOUP is a box, right? And it hangs on the ceiling, and it goes it's almost like Mr. Mr. Roberts' neighborhood where he has that little train or whatever. Imagine a train going throughout the factory. That's essentially what it is an overhead train where it takes all these wafers from point to point to point. This right here is a robot right here. Look very sleek, very dynamic, right? This right here is a wafer. That robot is all these are arms. Sorry, these are positions that you program, like a device, like a little device, like a PLC device, or you program via computer. All you're doing is it's called you're storing what storing not sessions, but you're storing stopping point. Well, right. So when what the arm does is goes, stops, turns, stops, go, stop. See that? Okay, and this is a wafer itself right here. Most likely, this is. don't know what kind of tool this is, but so each one of these little things right here, that's a wafer or that's a actual chip in your computer. So you see each one of those little square looking things, that's your computer. That's your essentially that's your CPU essentially, right? All of those CPUs, right? And not all of them are going to be usable, right? Not all of them. Sometimes it depends on the wafer. It's 200 millimeter, 300, 400 millimeter size wafer. You're going to yield more die or more CPU. And each one of those. So imagine, right? You have 25. So you have 25 wafers, right? Then you have, let's say, 500 chips. Let's say, right? So 500 times 25. Okay, that's a lot. And then times that by, and it takes probably like 30 minutes to process one wafer. One, I'm sorry, one FOUP. It probably takes like a half hour. No, maybe like no, maybe 40 minutes, something like that, to process one. Right? You're looking at, and it does it high value manufacturing. Some of the fabs in like Arizona use high value manufacturing. Well, overseas, they have fabs as well. Thing. Yeah, so this is the wafer. So yeah, that's that FOUP going up, and this is a person going and putting that FOUP, sorry, the FOUP container in. That's a picture of a FOUP. That's a picture of a person, analyzing. So this would be here. This most likely. So it's a clean room. That person is looking at probably analyzing. This is probably like a test tool where they're analyzing for um, clarity or they're processing. Yeah, yeah. Here's another example of the hoops going down, coming down, and they go back. Shinko is a company that makes wafers actually, or makes hoops. So here's a lot of the fabs, right? You probably see Germany, Ireland, what is it? Italy, Turkey, maybe. You have Indonesia, Taiwan, Japan. Surprised that they have a fab here. Maybe nevertheless, because really it's you don't want it in a humid environment. Yeah. So this is essentially is the wafer, right? You don't, but imagine like a house stacked one another. Each floor is like a process. So the bottom process is like your metal, like your silicon substrate, which is like tungsten. I think it's tungsten. Tungsten, I believe. Yeah. So the tungsten is like the where the interconnect, right? The little feet, if you right, to connect to um, the base, essentially, right? And then you have your silicon. That's your silicon substrates. That's your actual wafer. Then you have your different levels, right? So you might have copper. I don't think you're going to have a limit. Mostly it's copper, but so each one of these like, rooms or floors will represent like an on-off switch. Essentially, that's what's going on. So what happens is that wafer, that's that goes through a lot of processes, 10, 12 processes, something like that. And each time might go plate, like copper deposition, then it goes to litho, which is like carving out basically a little space to plate again, and so on and so forth, right? You see the different layers, and then this is inside a clean room. Now, it's not a copper, right? So you have copper and non-copper. It's not a copper. You know why it's not copper? Because the person's wearing not they don't wear a copper color uniform, a bunny suit. That's how you know it's not copper. And these clean rooms are usually 1 micron dust or something like that, usually in there. This is not in the tool side. This is the on tools. Yeah, this is again the robot taking wafer, putting it in the FOUP, and this is a picture of what you might see in your actual Intel chips or whatever chips, AMD, the other ones. Yeah, this person here is setting up the recipe probably. Here's a picture of a person putting on their bunny suit or they go in the clean room. Oddly enough, right? In a clean room, sometimes you see these people in the in the clean room, and you don't see them before they get dressed and all that stuff. You don't even know who they are. We talked to them for months or whatever, and you have no idea who they are because you don't see them outside. Yeah, so this is they get their little the bunny suit on, and floors are, you have meeting rooms in the fab. Inside the clean room, this is obviously not in the clean room, the uniform. Yeah, this is training as well that goes on to that company. So yeah, so here's like a lot of times what'll happen is they have like what's called pass down meetings. So they'll get a group together and talk about what we're doing today. Here's what's going on. Everybody has pagers around call. See the pagers right here. Look at the technology involved in the. Yeah, this all came from like essentially. So Intel, if you didn't know, right, it came from Gordon Moore, Robert Noyce, and Morier, I think, or Moray. So they all came from Shockley Semiconductor. Started their own company, Intel. Right? That's essentially what's going on now. Intel is the the premier out of all the other silicon manufacturing in the world. Intel is it. They do the right. Yeah, another test tool, whatever that test open tool, right? Just testing the wafers themselves. Yeah, and then here's a picture of a robot. Very sleek, right? I mean, program where the robot goes, what it does, what function it has. Probably going into a chamber, and usually people don't pick up wafers, right? Usually, other than they, that's maybe they're doing some kind of analysis on that wafer, and they're not using it. Right? Not going to be used because it's out and about in the. No, they're not much. So yeah, I hope you've enjoyed this little overview of the semiconductor. What they do usually, their jobs, what their name of their jobs are, or it could be like thin films engineer, could be semiconductor and engineer and that sort. So thanks. See you in the next one.